Okay, so this time I'm going to go through example 14 just because I do think it's another one which is pretty tricky when you first read through it, so perhaps this video will help. Um, like I say, the exercise will take as well, like, I'm happy to give the 2 hours that we've got for the rest of the week on just getting all of this exercise done. It's a tough little exercise, so give it a really good go. Try and get a question right, try and get the questions right on your own without getting too much support. Spend time on them. Anyway, here we go. So we're given that s equals e to the I theta plus e to the 2 I theta plus all the way up to e to the 8 I theta. Now, when you see that, especially when the way they define P and Q underneath. I think they do it slightly later in the question, but it doesn't matter. Bear in mind that e to the I theta is cos theta plus I sine theta, yeah? And e to the 2I theta is cos 2 theta plus I sine 2 theta, and so on and so forth. So P is just the real part of S, yeah? And Q is just the imaginary component of S, yeah? Remember, the imaginary component doesn't have an I on its coefficient. It is just like whatever the imaginary component is can be. So, for example, if you had the complex number 2 plus 3i, the real part is 2, the imaginary part is 3, yeah? You're looking for the imaginary component of that number. So, okay, we've got this, and we've got to prove that S equals that. Now, straight away, you've got no choice really. You're going to have to use A times r to the n minus 1 over r minus 1, which is all we're really using here because that is a geometric series, yeah? And it's a geometric series with first term e to the I theta. Its common ratio is also e to the I theta, so I'm going to write that as e to the I n theta minus 1 over common ratio e to the I theta minus 1. Okay, right. So first glance, it's like, right, how are we going to do that? Oh, I've made a slight mistake as well because what is n here? Well, n is 8. So this is 8 I theta. Let's just rub that out. There are 8 terms in that sequence, not n terms. Before, I think I was using the generalization n. This time there are 8 terms, so we've got 8 I theta minus 1. Now, if you notice straight away, they've got a 4.5 I, 4.5 I theta, if you like, or a 9 I theta over 2. And also sine theta over 2 on the bottom. That tells you that you really want to be working with theta over 2s. And that's why I'm going to multiply top and bottom by e to the minus I theta over 2. E to the minus I theta over 2. Because it's immediately going to help me, minus in there, it's immediately going to help me use these kind of formulae, but with theta replaced with theta over 2. So what do we get? Well, when we do that, we're going to get e to the I theta over 2 there. We don't have to touch this for the moment, do we? We can leave that. And this is going to become e to the I theta over 2 minus e to the minus I theta over 2. Now, I'm loving the bottom because the bottom is already agreeing with the answer in the question. It's sine, or well, it's close to it anyway. It's 2i sine of theta over 2. Granted, the 2i is there. That's possibly, oh, maybe that will cancel later. But so far, it's looking good. Now, the trick they use here is to say, okay, we really need, because, I mean, the hint, you always look where you're going in these questions. Always look where you're going. The hint is the sine 4 theta. And sine 4 theta is going to be something to do with, oh, why have I got a minus there? Sorry, you probably noticed that I've misrepresented that, miscopied that. I think it's just as I'm writing this down. There we go, e to the I theta minus e to the minus I theta. Well done if you spotted that. So, okay, if we're going to do this, we really need a sine 4 theta, and a sine 4 theta is going to happen if you have e to the 4i theta minus e to the minus 4i theta. Now, how can we do that? Well, we could imagine. Basically, we times what we're going to be doing. If I can do this in colouring, I'm going to times this by e to the 4i theta, and I'm going to divide this by e to the minus, well, I'm going to divide this by e to the 4i theta. I'm just worried about my writing here. It's really tricky teaching through YouTube using a graphics tablet. It really is. It's not easy. E to the 8i theta. Let's make that nice and clear. So I'm going to times this one by e to the 4i theta and compensate by dividing this one by e to the 4i theta. So if I times this by e to the 4i theta, I actually get e to the 9i theta over 2. I've times it by e to the 4I theta. And I'm going to compensate by dividing the right-hand side of the product by e to the 4I theta. That's essentially what they've done. Yeah? Okay, now that would give me e to the 4I theta minus e to the minus 4I theta. And now I'm looking real good, because that's exactly the same as their answer now, really, isn't it? Because we get e to the 9I theta over 2, and then we get sine 4 theta, well, 2I, sorry. Let's just take that back. Oh. Times by 2I sine 4 theta over 2I sine theta over 2. The 2i's cancel, and you've got their answer. Great, all well and good. And the next part of the question is where they say find P, and I'm actually going to write it down. I think they tell you the answer for P, but I'm just going to say find a simplified, they say prove P equals cos of 9 theta over 2 sine 4 theta cosec. Yeah, and this is really, it looks far more difficult than it actually is. Some of you may be able to spot straight away that this is actually very similar to that answer. We've got the sine theta 4 theta there. We've got the cosec theta over 2 there, because that's the same, timesing by cosec theta over 2 is the same as dividing by sine theta over 2. Yeah, so we're going to prove that. We're going to do the same thing for Q and so on and so forth. So, okay, P is just the real part. Do you remember me saying it's just the real part of S, yeah? Now, S, God, this handwriting is getting bad. Yeah, P is just the real part of S, which is the real part of e to the 9I theta over 2 sine 4 theta. And then we've got cosec theta over 2. Now, both of those are real, yeah? Now, the reason that this is real is if we expand that, that's actually going to be just cos of 9 theta over 2 plus I sine of 9 theta over 2. And then we're going to multiply that, let me put this in square brackets, by sine 4 theta cosec theta over 2. Now it's obvious, yeah? I say that hoping that you see it's obvious. The real part of this is going to be not the bit which is times by I sine 9 theta over 2. That's the imaginary part. That's Q. The real part of P is simply going to be cos 9 theta over 2 multiplied by sine 4 theta cosec theta over 2. Likewise, the imaginary part, which is Q, that's simply going to be sine 9 theta over 2 sine 4 theta cosec theta over 2. And hence, when you do P over Q, loads of it's going to cancel. Is it P over Q they do? Or it's Q over P. I apologise. So when you do Q over P, you're going to have sine 9 theta over 2 divided by cos 9 theta over 2. And everything else is going to cancel because they're exactly the same. Look, there they are. Let me just circle them in red. That's going to be divided by that bit. That's going to be divided by that bit. So they're all going to cancel. And you're left with sine over cos, which is tan. And so you get tan of 9 theta over 2. Yeah, so that's the kind of stuff which is going on in this exercise. I hope it makes sense. Please do get in touch. The Maths Help Desk is ready. I haven't heard from one person yet from Double Maths, so I'm guessing at the moment that this chapter is pretty straightforward. We're going to go straight on to exercise 1F when we get back. Okay, keep up the hard work. Let me know if you're stuck, and I will be posting solutions to these questions probably at the weekend. Okay, best of luck. Bye-bye.